Welcome to STEM Professionals. In this video tutorial, we're going to discuss three things. The first one is significant figures. The next one is scientific notation. And finally, the rounding off error. So let's start with the video tutorial. Now, first we're going to discuss the significant figures. Now, when a length, mass, or a time is measured in an scientific experiment, the result obtained will have some inaccuracy or uncertainty. And this inaccuracy or uncertainty can be caused by a number of factors, like the limitation of measuring device itself, or it can be due to the sense and the skill of the person performing the experiment. So you can write senses and skill of the person. And there can be other reasons also. For example, here you can see that two persons are measuring distance by using scale, and suppose the distance measured comes out to be as 50.5 centimeter. Now this measured distance will not be accurate due to the number of factors that I explained earlier. Now the level of uncertainty in a numerical value is indicated by the number of significant figures. Now, what are the number of significant figures? So the number of significant figures in physical quantity is equal to the number of digits in it that are known with certainty. So let me take an example here. We need to find the walking speed of this person, as you can see in this video. Now suppose the person covered a distance d in time interval t, then the speed would be equals to the ratio of the distance covered divided by the time. Now suppose that the distance traveled by the person comes out to be as 61.4 meter. Now each of these three digits is known with certainty, though the digit that follows the 4 is uncertain. Hence we can say that the distance d has three significant figures. Similarly, the time taken to cover this distance comes out to be as 8.5 seconds. It follows that t is known to have only two significant figures, because you are not certain of the digit that follows the 5. So that is why we have only two significant figures for time. Now our aim was to calculate the speed. So speed would be equals to distance divided by time. So distance is 61.4 divided with the time is 8.5 second. So that would be equals to 7.2235 meter per second. Now clearly such an accurate value for the speed is unjustified, considering the limitations of our measurement, because this is not accurate. So the rule for significant figures when we are multiplying or dividing is given by this statement, that is, the number of significant figures after multiplication or division is equals to the number of significant figures in the least accurately known quantity. So here the least accurate known quantity is time, because it have only two significant figures, which is 2. So therefore the answer should be given with two significant figures. So we can write this speed to be 7.2 meter per second. Therefore, the speed for the person is 7.2 meter per second. So this is the correct way of representation. Now next I'll be giving one question for you guys, that what is the distance covered by the person. Distance we have to calculate. If the time taken to cover that much of distance is 10.5 seconds and the speed for the person we are given to be 5 meter per second, and you have to write the answer for the distance in the comment box below. Now next I'll going to discuss the rule for adding or subtracting the significant figures. So this is the rule for adding or subtracting the significant figures, which is the number of decimal places after addition or subtraction is equal to the smallest number of decimal places in any of the individual terms. So let's take an example to understand this statement. Suppose that you calculated time t1 to be 16.74 second and time t2 you calculated to be 5.1 second, and you need to calculate the total time t. So t will be equals to t1 plus t2. Now here you can see that they have this is 4 significant figures and here it is 2 significant figures. Now if you add these two numbers, it will comes out to be as 21.84 second. Now this answer would be inappropriate according to this statement, because if you see the number of decimal places in this term t1, there are 2 decimal places, and in the second one we have only 1 decimal place. So the answer should be written with only 1 decimal place. So the correct answer would be, according to this statement, will be 21.8 seconds. So this is a correct way of adding or subtracting the significant figures. Now I'll be giving one more question to you. Suppose that the weight of the first person is 40.52 pounds and the weight of the second person is 35.6 pound, and you need to calculate the total weight. So this is what you have to calculate. Basically you have to add these two numbers by using this rule, and then you have to write your answer in the comment box below. Now next we're going to discuss the scientific notation. Now the number of significant figures in any quantity may be doubtful due to the presence of zeros at the beginning or the end of the number. For example, you measure the distance to be 6500 meter. Now the 2 zeros here could be significant figures, or they could be zeros that simply shows where the decimal is located. Now if you consider the zeros to be significant figures, then the uncertainty in the distance would be roughly a meter. But if these 2 zeros are not significant figures, the uncertainty would be nearly 100 meter. So to remove this type of confusion, we write the distance in scientific notation, that is as a number of order unity times an appropriate power of 10. Let's take an example here. We can express the distance to be this 6500 meter can be represented as 6.5 times 10 to the power 3 meter. This is also the one way, but here you can see that it will have only 2 significant figures, 6.5. So only 2 significant figures are there. Other way around, you can also write the distance to be 6.500 times 10 to the power 3 meter. You can write this way also, but in this case the significant figures would be 4. So this is the best way to write your answer. Other way around, you can take one more example. The time you have calculated to be 0.000036 second. Now here in this value, the significant figures are only 2, because the preceding zeros only serves to fix the decimal point. And if you want to write this this time with 3 significant figures, we can write to be t is equals to 0.000036 second. Now the time will have 3 significant figures. Or other way around, you can also write the time to be equals to 3.60 times 10 to the power minus 5 seconds. So this is also in this representation, the number of significant figures is also 3. So this is the best way to write the term or your result. So this was the scientific notation. Now next I'll be giving one question to you, and you have to find that how many significant figures does these number have. The first one is 0.0210. Second, you can take to be 5.060. Third one you can take to be 1 times 10 to the power 5. So we have to write the number of significant figures with these 3 numbers, and you have to write the answer in the comment box below. Now the last topic that we're going to discuss in this video will be rounding off error. So let's directly take an example to understand this. Suppose that the distance covered by the person is 25.3 meter and the time taken to cover this much of distance is 2.7 second, and we need to calculate the speed. So speed will be distance over time. So distance we have 25.3 divided with 2.7. So that will be equals to 9.3704. But since we have 2 significant figure in time and there are 3 significant figures in distance, so we have to write our answer with only 2 significant figures. So the speed with 2 significant figures will be equals to 9.3 meter per second. But you may find that the answer written in your book is 9.4 meter per second, and this is usually due to round off error. Now round off error occurs when numerical results are rounded off at different times during calculation. Now let's see how this rounding off works. Now if you see the next digit after 3, it is 7, which is greater than 5. So we're going to round off this 3 with its next number, which is 4. So that is why you may find the answer to be 9.4 meter per second. Other way around, if you might have got this answer to be, suppose we are supposing that this is 9.3460. Suppose you might have got this answer, then this 4 is less than 5. So this 3 would be as it is and the answer would be this value after rounding off. So this is the way the round off works. So this is all with this video, and in the next video we're going to discuss the conversion of units and scalar and the vectors.